Bismillah. Welcome to ThinkMath. Today we solve an IB analysis and approaches question that connects trigonometry, the product rule, and tangent lines. Let theta be an obtuse angle such that sine theta equals 5/13. Part A, find the value of tan theta. Part B, line L passes through the origin with gradient tan theta. Find the equation of L. Let f of x equals e to the x times sine x minus 5x over 12. Part C, find f prime of x. Part D, line M is a tangent to the graph of f at point P. Given M is parallel to L, find the x-coordinate of P. In the interval 0 to 3, Part A, we are given sine theta equals 5/13 and theta is obtuse. Look at the right triangle. Opposite equals 5, hypotenuse equals 13. By Pythagoras, the adjacent side is 12, since 5 squared plus 12 squared equals 13 squared. Now theta is obtuse, meaning it sits in the second quadrant. In the second quadrant, sine is positive, but cosine is negative. So cosine theta equals negative 12/13. Using the identity tan equals sine over cosine, tan theta equals 5/13 divided by negative 12/13. The 13ths cancel. Tan theta equals negative 5/12. Part B, line L passes through the origin and has gradient equal to tan theta, which is negative 5/12. Since it passes through the origin, the y-intercept is 0. Using y equals mx plus c, the equation of L is y equals negative 5x over 12. Part C, we need to differentiate f of x equals e to the x times sine x minus 5x over 12. The first term is a product of two functions. We use the product rule. The derivative of u times v equals u prime v plus uv prime. Let u equal e to the x, so u prime equals e to the x. Let v equal sine x, so v prime equals cosine x. Applying the product rule to the first term, e to the x times sine x plus e to the x times cosine x. The derivative of negative 5x over 12 is simply negative 5/12, a constant multiplied by x. So f prime of x equals e to the x times sine x plus e to the x times cosine x minus 5/12. We factorize e to the x from the first two terms. F prime x equals e to the x times open bracket sine x plus cosine x close bracket minus 5/12. Part D, M is the tangent of f at P. We are told M is parallel to L. Parallel lines have equal gradients, so the gradient of M equals the gradient of L, which is negative 5/12. That means f prime at the x-coordinate of P equals negative 5/12. Substituting our expression for f prime, e to the x times open bracket sine x plus cosine x close bracket minus 5/12 equals negative 5/12. The negative 5/12 cancel from both sides, giving e to the x times sine x plus cosine x equals 0. Now e to the x is always positive, it can never be 0. So we must have sine x plus cosine x equals 0. Dividing both sides by cosine x, tan x equals negative 1. In the interval 0 to 3, that is 0 to 3 radians, the solution is x equals 3 pi over 4, which is approximately 2.36. And we confirm 3 pi over 4 is about 2.36, which does lie in the interval. Look at the graph. The blue curve is f, the green line is L through the origin. The red line, M, is the tangent at P, and you can see it is parallel to L. Point P is exactly at x equals 3 pi over 4. And there you have it, a complete IB question connecting trigonometry, the product rule, and the geometry of tangent lines. Remember the key steps: obtuse angle, go to the second quadrant; product rule, u prime v plus uv prime; parallel tangent, set f prime equal to the gradient of L. Follow ThinkMath for IB, A-Level, AP, and IGCSE mathematics. Links below.